Hello, everyone. Welcome to Best Practices for Measuring Your Code Pipeline. Today's webinar is going to be really cool. We will have code, live code that we're showing to you. We want to explain to you how to set up your code pipeline and how to hook in New Relic and get the measuring you need to move forward with confidence. Before we start, we've got some housekeeping that we want to go through today. First of all, this webinar will be recorded, and a link to the recording will be emailed to you shortly afterwards, so you can take a look at it and walk through the code yourself. Be sure and ask any questions you have via the questions panel. The GoToWebinar control panel has a little opportunity for you to click down there and ask your questions, and we'll get to as many as we can. And finally, there will be a brief survey after the webinar for any additional questions or feedback you have. So our speakers for today, myself, Tori Wielt, I'm a Senior Solutions Manager at New Relic. And we also have with us Eric Mittelhammer, who's a Solutions Consultant at New Relic. Eric, I'm so glad you're here today.
Thanks, Tori. Happy to be here and happy to share this content with you guys.
Yeah, this is going to be great. I'm pretty jazzed about it. So, for those of you that don't know New Relic, we can be your partner on your DevOps journey. We're a company that's helped a lot of companies, small unicorns and large Fortune 100 companies, making their journey in DevOps. And how do you do that? And how do you move along so you can move forward with confidence? We have over 16,000 customers, and I just had to change the number this morning. We were 1.8 billion, now we're 2 billion. So we are consuming data at a large scale, and we can take in all that data for you so you don't have to worry about your monitoring data, where you're going to hold it, how you're going to query it, all those things. We take care of that for you. So New Relic, a little bit of history about us. We started out, we only monitored Ruby. And we started out, we had the siloed teams. We were releasing not as frequently as we like to, and we were very reactive in our behavior. And we realized that we had to change. We weren't going to be successful unless we changed our architecture and changed our processes. So now we are running over 200 microservices. We have 50 plus engineering teams. We do have SREs on board. I'll just give a plug for the previous webinar that we did about how to be an SRE in this world. You can take a look at that. And we regularly deploy our software between 20 and 70 times a day. And the teams are proactively watching what they deploy. So how are you going to automate your code pipeline as you move from continuous integration to the continuous deployment? You want to get the code out there as quickly as possible, but if you're not delivering quality software, then it kind of defeats the purpose. So we want you to be able to move quickly with confidence, and this is what we're going to help you do. And the way you need to do it is you need to measure your full stack. So today we're going to use AWS tools to create a no-touch deploy and commit pipeline, code pipeline. Yay, that's great. And base monitoring tools, something like CloudWatch, that's great, but that only takes a look at the bottom of your stack, what's going on with your virtual hardware. So how do you identify, these changes are coming much more quickly, how do you identify what these changes you introduce, both at the infrastructure level and the application level? Is it making the user experience better or worse? Are people getting what they need? Are they seeing errors? Is it taking a long time to load things? How are you going to know how you're going to do that? So we're going to show you how to hook up monitoring information and have it available to you. So let's build a pipeline. And this is a high-level look at what we're going to do today. We have a sample app, and we're going to instrument it with New Relic. We're going to enable your code pipeline. We're going to send the metrics up, and then we're going to take a look at those measurements and then figure out where we need to make improvements. So with your pipeline, we're going to take things like the source code. So we're going to collect data like the commit metadata, the build status. results of your test, your deploy status, and performance metrics. We're going to send it all down to New Relic, and then you can take a look at it. So enough babbling from me. I'm sure you want to hear from the engineer and figure out how you're going to build this pipeline. And Eric's going to show you how easy it is. And I will tell you that we do have code up on GitHub, so you're going to be able to try it yourself. And we'd love for you to give it a try and give feedback. And don't forget, if you have questions throughout the webinar, please put them in, and we'll try and get to as many as we can. So without any further ado, Eric, show us what you've got.
Thanks so much, Tori. Welcome, everybody. Thanks for joining. As Tori mentioned, we're here to discuss how to measure your code pipeline. And just to give you a high-level view of the types of things we're going to cover, we have a live running code pipeline, so active commits that are triggering builds and deploying a tiny app that I built. I'm going to show you what data you want to collect from your pipeline, as well as how that augments the data that you're already getting from your application. We're going to show you how to send that back to New Relic, and then how to create dashboards like the screenshot of the one you see here, and how to put it all together in a way that makes sense. So I think let's just start quickly by reviewing what a code pipeline is. So for the purpose of this demonstration, I'm using the tool AWS Code Pipeline, but there's in the DevOps world, you hear terms like CI, CD, continuous integration, continuous delivery, and there's a lot of tools that fill this purpose. So, for example, Circle CI is a SaaS product, or Jenkins if you're self-hosting. Essentially, they're tools that manage the progression of states of a application from its source code to deployment, and essentially just make sure that everything reaches the checkpoints as it goes through those phases and will either succeed or fail. So the internals vary from system to system, but overall, the flow will be the same for no matter what tools you use. So the idea here, and if you look at the screen, you can see this configuration that I have and this simple pipeline that's running this simple app. In the vocabulary that's used in this particular product, these large boxes, they're called stages, right? So each pipeline has multiple stages, and the smaller boxes within them are called actions. So multiple actions make up a stage, and when all the actions have successfully completed in that stage, it moves to the next stage. And as you can see, we actually have real activity going on, and I'll show you how that manifests itself into monitoring and data as we go deeper. But the general idea is that we're going to watch how code progresses through here and how we get the status from each one of these phases and how we use it. All of the code is in a GitHub repo that you'll see will be linked at the end of the deck here. A lot of the documentation about the tools and the explanation of what I'm doing is part of the README of this GitHub repo. So I'd encourage you to use this as a resource, a go-to. So any of the details that we don't get to in this presentation, hopefully will be covered in the README itself, especially when it comes to the documentation on the products themselves, and how I'm using them to get this flow. So this project is a small, tiny Node.js app that has an application itself, but also contains all the code for the handling the events and reformatting events and sending them to New Relic. So you get both sides in the same repo, so it's all contained in one place. Before we get going into the actual details, I want to just go over a few themes, and I'll just pull them up here on they're in the repo as well, but I'll pull them up here so you can see them, of the general types of things that we want to capture. And again, I just want to stress that this applies to any code pipeline, no matter what tool set you use. These are just the general themes that you want to concentrate on, and your implementation is going to vary a little bit depending on the source of your events, and where you're, transitioning from state to state. But to cover them at a high level, everything starts with source code management. So however you're managing your source code, you've got to be able to collect the data from any time something changes there. At least you want to get the author and the ID that designates that change. For something like Git or GitHub, that's going to be the hash of the head commit as part of a push event, and that's what we're using here, and you'll see that throughout. And you want to propagate that wherever possible. And what that means is that data that comes in, is at the root of this process and should propagate to every other event that occurs downstream, because in any scenario, when you come back and look at your pipeline, if you're either trying to analyze your performance or you're trying to troubleshoot an error in your code, you're going to want to know the state of the application and the source of that change. And this is the way you do that. As the pipeline transfers between states, you want to capture the time and status of each one of those state changes. So whenever a stage starts or finishes, you want to capture not only the fact that it did start or finish, but the status. Was it successful? Did it fail? And if you can get a reason for it, that's even better. This is going to help you set up alerts if you want to, blast everyone and point fingers and blame the build like we used to a long time ago. That's great. If you need to, watch metrics for internal goals, you want to see that you have more builds occurring, less build, or find out why less builds are occurring. This is the source of the data for that. You want to send the results of unit tests as well. That's something that is, a hard metric. The number of tests, pass or fail, is great to determine, the effectiveness of a unit test suite. That maybe the time that the unit tests take to run. If someone, adds something very large to the test that extends the time, you're going to find out exactly when that changed. If you have the ability to get metadata, say, for instance, the % code coverage you have in your tests, those are the kind of things over time. Maybe you have a goal for this quarter, right? An OKR, we need to get our coverage to 100%. You can monitor the progress on that by sending that metadata with every test result. Again, just to reinforce what I had said previously about your source code, not only do you want to propagate that information throughout the events that come out of your pipeline, but you want to integrate into your build process, taking that data and attaching it to the application itself. That way, when it's running in production, you're going to be able to associate any event that you get as part of your monitoring and instrumentation with the build and the source code change that it came from. And finally, once a deploy happens, say as the final step in a pipeline like this, you're going to want to send that to the New Relic REST API that records deployments. And the net effect of that is you're going to get a visual cue that we call a deploy marker as part of your, the charts that you'll see. And I'll show you the application that has those as we step through each one of these stages. So right now I just want to show you the high level view of the data flow. And this kind of, the blue box over on the left there represents the data pipeline, and it actually looks similar to the pipeline itself. But the idea is that we're showing this data propagate through from its sources, which would be GitHub and the code pipeline itself, as well as actually some of our code itself, because say something like unit tests, right? That's code that we wrote. And this shows, in this example, in this app, all the pieces that it takes to get that into New Relic. And you'll notice in the middle, you'll see those orange icons that represent AWS Lambda functions. And those are there because the data that comes out of those events may not fit exactly into the structure that we expect as an Insights payload. Also, there's you need to authenticate and things like that, and that's a good place to do that. If you're not using AWS or whatever you're doing, maybe you have your own internal service that can accept webhooks, or so anywhere that it makes sense for you to do that transformation, it'll work. And again, I encourage you to look at the code and use that as inspiration. If you happen to be on AWS and using Lambda, you can probably copy and paste and you're all set. If not, you can tweak it to your specific implementation. So let's start by talking about our source code, right? So all events start in GitHub, and here in this example, and GitHub has an event that's called a push, and I have subscribed using a webhook in two places, and I'll show you both those. But the first thing is that we send the webhook to a Lambda function that reformats that event and sends it on down to Insights, and the name of that function is get up to Insights. It's in the source code. You can take a look. But what I want to show you is what that looks like once it gets to Insights. So this is an example of an event that I've named GitHub push, and this is the data that we get right from GitHub. So you can see it's got the information on the person who made the change, the timestamp for when it was done, and the commit SHAs surrounding before and after that change. If you want, you can augment this with even more data. So if you want to track, say, the amount of lines of code that are changed and stuff like that, you can get that from GitHub, and that's useful to create, say, in a dashboard for monitoring your code pipeline, a chart like this. Now this is pretty simple. We're just looking at the number of source code pushes per developer, but maybe you have metrics based around how much code is being pushed on which apps, and if you have multiple apps, you can compare them and you can find out where all the activity is. After that, we have the same webhook that publishes to the AWS code pipeline, and I'll show you in the pipeline itself. That's represented by this action, and that's a standard integration. And again, you may have to figure out how that works in whatever pipeline or CI/CD tool you're using, but that's kind of a built-in feature. The documentation is linked in the GitHub repo. Essentially, what that does is it just takes the push event and downloads the source code and then feeds it on into the next part of the process, which here is the build stage. And the build stage I have here has two different actions in it. One is called tag build, the other is run unit test, and I'll explain how these work. This application happens to be Node.js, which doesn't require a compilation task. But if you did, say it was Java, Golang, something like that, you would do that here as well. And there's certainly metrics you can pull out of that. You want to find out how long it took to compile, or how many classes were result of the output, or anything like that. In this case, this is just Node, so we don't have a compilation step. But one thing to focus on here is this tag build. And when we run a build that comes through that process, we're given the metadata from the previous step. So I have this build task that will run a Node.js file that simply takes those environment variables and writes them out to disk. And that actually becomes part of the app itself. I'll show you the template. It'll end up looking like, it'll take on this format. It will overwrite this file in an actual running app. But what that does is it allows us to get the build information in the app itself. So if I click over and I look at our simple service, you can see here where we get the New Relic. We require the New Relic APM agent, which will automatically latch onto all our incoming, outgoing requests and record transactions. And here I load that file as a module, which will record that metadata in memory. And then I've now annotated with the custom attribute every single event that happens in this application. So no matter what, in a bigger application, obviously you're going to see a lot deeper code, and there may be other custom events and other things that we're recording. Any exceptions that are thrown are always going to have this data attached to it. And I'll show you how that looks. So a typical APM event, right? This is what, you get every transaction. And you'll see, the normal stuff that we record, right? The response code, the request timing, duration, all that. But here is the commit that was associated with the last build that was deployed. So as you go and you profile other parts of your application and you start to build dashboards out for specific things you want to measure, you can see how every single code change affects it, and you can trace it back to the source. And then, so back here to our information flow, is a good time to explain, the idea of, at this point, you'll see all these arrows that say state change, right? So what that is that's an event that is published by the code pipeline. And that doesn't know a whole lot about our specific code that's running or being built within it. But that's what gives us the start and stop state of all those state transitions. And we have a common Lambda function that will go and reformat them and send them to the Insights API, similar to what we did for the GitHub event. It's just using a different format and a different payload. But basically that allows us to build dashboards like this, where you see we have pipeline status, which is going to show the state of the last pipeline task that was executed, or just to count the number of succeeded and failed pipelines in a recent time frame, in this case in the last day. The duration of each, which also have the build number and the commit hash attached to them. So if there's an anomalous build that's taking a really long time, that's going to stick out here, and you can figure out, well, what was it about that one change that makes this build take so long? Why is it holding up the rest of the pipeline? No one can push code. What's going on? A log of all the recent pipeline events. And down here, we have an example of what I was showing you, where we now have a performance metric that has build information attached to it, again, by propagating that build info to it. You may want to track your historical build status. So over time, you have a goal to, have less than 2 fail builds a day or something like that. Over time, you can plot that and track it and see how you're doing as for your team's internal goals. The next phase runs our unit tests. And since this is self-contained within the application itself, we don't need any intermediary transformation functions, because we're writing the code that handles the unit tests. And again, it's linked here and explains on how you can use the products in AWS to run that phase and then get the output. But again, send the output to New Relic as an insights event that records the number of pass tests, the number of fail tests, and you're going to get a metric that shows the current state of unit tests. And the last build, obviously did not have 100% passing unit tests, and we can see that there. You could plot it over time as well. Again, maybe you have a legacy repo that's has unit tests that fail all the time, but you still have to deploy anyway, and it's a goal for you to go back and clean that up. This is how you're going to measure that progress over time for your team. You can see how you improve, and like I mentioned before, if you have a code coverage goal, that's a great thing to track as well. And finally, when we have a deploy event, we have the state change event that goes to the standard through the standard transformation and gets recorded as an insights event that we can use to create the data that I was just showing you. But we also have the ability to record a deployment with New Relic's APM REST API that has a little bit of a different format. So we create a listener for a specific type of state change event that is when a deploy succeeds. And again, I've documented that as well in the Git repo. Goes through a slightly different transformation and then posts to New Relic's REST API to indicate that a deployment happened. And that will add a visual marker. So each one of these vertical lines in your APM dashboard represents a deployment. You can see here, obviously, there was a big change in performance, and we can correlate it to this particular change that seems to have caused it, and that's revision 43B0AC. And if I go back to my dashboard, you'll see that this one build, wow, that's taking a lot longer than the others. And that's a direct correlation to that particular deployment that caused a performance degradation. And of course, in real time, hopefully you'll get an alert, when that happens. But you can use those deploy markers to, trace back to the exact change that caused that degradation. So, like I was saying, this is the overall flow. All the information and all of the details on how to do this is in this repo as well as the source code. There is documentation that explains each phase and what we're doing, and links to the pieces of source code as well as the AWS documentation for that product. And like I said, this should inspire you to think about how you're going to implement your pipeline using the tool set of your choice. But if you happen to be using AWS, then you might be able to just drop this right in and be up and running pretty soon. So thanks, and I'm looking forward to answering your questions.
Wow, thanks, Eric. That's really great. I'm hoping people will go out to GitHub and take a look at it. And this is some really important information. And we've found that the companies we work with, a lot of the battle is getting agreement about what to measure. So this kind of might trump that and give people a good place to start in terms of what to measure, what to take a look at. And we're encouraging you to go out to GitHub. The code's at GitHub/New Relic webinar, and we will have a discussion topic up on the Explorer Hub at the New Relic community at discuss.newrelic.com, and you can take a look at that as well. And also as a reminder, this is part of a webinar series. As I said, we had one on SREs and how to do the SRE stuff, even if you're not Google. So take a look at that, register, and grab that recording. That's a really good one. And we've got an upcoming webinar called Setting SLOs and SLIs in the Real World. And we have a couple engineers from our team up in Portland that are going to discuss how you can set your SLIs, understand, and it's pretty interesting. They even talk about charted databases and the difference that introduces into setting your SLOs and SLIs. So I encourage you to take a look at that. So we're going to take a moment to see what your questions are. Feel free to ask questions up in the GoToWebinar control panel. And you can also go to newrelic.com/DevOps to get more information. Eric, one question I see is, what's the latency on this? So the information that you're grabbing, how long does it take for you to grab this information and then have it appear in a New Relic dashboard?
So it's a good question. The answer is it depends. Usually it's less than 1 minute. It depends on the source of the event. So the idea, like for instance, events that come out of the code pipeline, you're going to see them very quickly in the dashboard only because they're a single event that uses an API to post them. In events that come out of, say, APM agents, there's a collection time, right? We harvest events for a while and then post them, once a minute. So there's the latency between that minute and then the post, and then by the time it, aggregates itself into the dashboard. But it's usually within seconds. Okay,
nice. Seconds are good. We like that. Another question. This demo was based on quantitative info. What about more qualitative information, like which specific tests failed over time? How would you grab that information?
Yeah, I encourage you to look again at the script that submits that data, and it can kind of give you an idea of how. Essentially, Insights is a NoSQL schemaless key value store. So you can store anything in there that you want, and then you can query and aggregate on it either in a quantitative manner, if you want to, use standard, aggregation, sum, average, difference, all that kind of stuff. Or if you want to count and group by things that are qualitative, like you said, which unit test, if you can export, it all depends on the technology you're using and the test suite you're using. I know, for instance, the tool I happen to use, and you can see it in the repo, is Mocha, right? And the Mocha report that gets output actually does have a summary of every single test, and it's the name of the test and the status if it passed or failed. I didn't go through that, loop through that and record a metric for each of that, but you certainly could. In that example, you could just simply loop over that list and take account of by test name and its status, and you could pipe those events into Insights, and then you can aggregate on that over time. So you can say wherever this test name equals this, or group by this test name, how many passes and how many fails did I have?
Excellent. Thank you. Another question. How do you filter noise and ensure you don't add unwanted data to Insights? I'm not sure what they mean by noise here, but maybe you will take a guess at it.
So, the good thing about the Insights API is that, you are in control of the events that you send. Really the idea of custom, either adding custom attributes to existing events, like I showed with the, adding the build number and commit SHA to your application, and then sending custom events in, like the pipeline events. Those are completely custom themselves. The idea is that you're always trying to make a correlation between something that is happening in your application and then something that, in the case of a custom event, is outside that application, and you're in control of that. So if you're going to have to figure out the data that's coming out of your, what's available to you in your, say for example, in the AWS Code Pipeline product, the information that's available in the event payload there, you just have to take a look at it and find out, is this relevant in any way to anything downstream? And if so, you drop it in. I always err on the side of sending more data because you can't go back in time and add something that you didn't have. So I always like to add more first and then trim it down later.
Yeah. Actually, we had a engineer present yesterday, and he talked about some stuff in the UI that he actually worked for New Relic and had a whole lot of stuff instrumented in the UI, and then they were able to answer some questions that they, retroactively. It's like, who clicks on this button versus that button? And since they kind of quote unquote over instrumented, they were able to answer that question. So that's great. I can handle this one. Is the Insights module an add-on to New Relic or something that comes standard with account? So Insights is a separate product from APM. So if you're using APM, you would have to get Insights as a separate product. We have we have a browser product and some other products as well. So I encourage you to reach out to your sales rep and talk to them about using Insights. Let's see. Wow, all the questions are floating in. This is amazing. Okay, what primary metrics in a deployment pipeline would you create alerts for? So where do you start on your alerting, I guess, is a good question.
Yeah, it's a great question. So I'll preface that with the, I hate to use the word, but disclaimer that it all depends on your org and what's important to your teams and the kind of things you like to monitor. But of course, there are ones that stand out that are usually pretty obvious, and that is going to be the primary one is the success or failure of a build, right? That should be something that if you've got like capabilities of how you do your routing or whatever your notification channels are, right? For instance, Slack is a great example, right? If you're notifying in Slack, and if if you're able to get your Slack usernames as part of the metadata that you attach to a commit, or the other way around, if your Slack usernames happen to be the same thing as your GitHub usernames or anything like that, you could tag somebody at somebody that the build failed and notify them. Other than that, you want to track the amount of time builds are taking, because that can be something that degrades over time. And like I mentioned when I was showing the actual metrics collection, if you've passed your commit SHA through, you can find out which one of those builds are the ones that cause the most degradation, and that's the kind of thing that a lot of times is slow. It gets a little slower before you know it. People are waiting 30, 40 minutes to see their changes propagate. So you build time and tracking that over time correlated to commits is important. And I think, in general, like I said, I like to always have the status of unit tests in there too, because that's something that, especially if you've got a lot of projects or a lot of apps, and in the day and age of microservices, a lot of times you may be focused or siloed on a particular application, either exclusively or just for a set period of time, and you may not be in tune with what's going on in the other apps, and unit tests are always such a good marker of the quality of the application, and especially when it comes to code coverage. So I think those are pretty much the big ones that you want to focus on.
Excellent. We got a couple more questions and we'll wrap it up here. How do you handle issues surrounding flaky tests?
Yeah, so that's a great question. So if you're, the idea a lot of times, maybe you have an integration test that relies on an external service, and that test is gonna fail periodically. So hopefully your build system itself has, your test framework itself has something built into it that you can mark a test that it's okay to fail, or that it just is a warning and doesn't fail your whole build. As in terms of alerting, if you were to say you wanted to alert based on the failure of a test suite, you can use the query language in Insights, NERCL, and you could single out that one test and either ignore it from the computation of deciding which tests pass or fail, or you could make separate queries and alert according to different alert policies based on the tests themselves. So that if you have a test that's sensitive and you don't need to be alerted every time that it fails, it's great to record the data and have the fact that it failed in Insights, but you can ignore, or you can set the sensitivity for alerts less on that one test, especially if you're passing, or if you're passing the test name into the Insights payload.
Excellent, thank you. So we've got time for one last question. I'd like to be able to create New Relic dashboards for singular applications, as well as dashboards that would provide a higher level overview of collected data from several applications. Is this possible with New Relic?
100%. And it's actually a very common use case that we see a lot of our customers use. So the idea is that you'll have an application team that is, has their specific set of dashboards that they're concerned with, that have very deep metrics and very specific, things that they're measuring in those applications. Maybe you're measuring, a few key transactions that that are sensitive and are kind of the bellwether for your application. And then, because of the way that the data is structured and the way that accounts are structured, all the applications that are under the same account can then be pulled into this a higher level dashboard that maybe only shows average response times or average error rates, or if you want to put in high level business metrics, like if Insights is a great tool to add things on. The use case we always use is every time someone in an e-commerce site, you add something to a shopping cart, you record the amount of merchandise that was in that cart, and then you can pull those things together at the topmost level, because that has the most general focus and shows the general health of your application.
Great. Thank you, everyone, for attending today's webinar. You will get a link that'll have a copy of the recording. And as you know, the code's out on GitHub. I'm assuming you're pulling it down now and going to give it a try. Please join us out at the New Relic Explorer Hub. Let us know what you think. Let us know what questions you have. We really appreciate you joining us. And thank you so much, Eric, for sharing this information today.
Great. I enjoyed it. Thanks, everyone.
All right. Thanks for joining. Bye-bye.